All right, so here we go. We are going to have intense focus. We're gonna forget about the atrocities of parking. Let's focus. Okay. So welcome to the screencast, Hannah. Chapter 2 practice test. Ideally, we go through the practice test, and then we'll go through 2.4 extra practice. Once again, both solutions for these have been up since Friday. Wonderful. And I realize if you celebrate the new year, I mean, you couldn't see it, but you could see it Sunday, or last night, or today. Cool. Chapter 2 practice test. So let's just see. I'm just going to call people, and let's see, let's be with it today. Let's do it lively. Let's be lively and go through as much as possible. Perfect. All right.
Okay, so you plug in 7 for the first one, and then 39 minus 14 equals 25, 3.5, so it's 5.
Beautiful, it's 5. All right, how about the next one? Let's just go down the row. Noah, what this next one?
You plug 0 for x, and e to the 0 power is 1, so 2 plus 1 is 2.
Wonderful. So limits, we always try plugging in first. If it works, awesome. It's when we plug in and we don't get a nice number, that's when it doesn't work. So when I say not a nice number, I mean when I plug in my number and I get 0 over 0. It's called indeterminate form. Remember, if I plug in a number and I get 0 over 0, that's indeterminate, and that's when we have to start doing fancy stuff. But ideally, try plugging in first. These first two should be like your little, I don't know, cake. No, it's your apples and honey. There you go, little apples and honey for you. Should be nice, easy points. We should be able to just like knock those out. All right, let's go, Maya. How might I do this? Oh, the next one.
I knew. Okay. Well, I know sine x over, sine, isn't it 1? Wait, hang on.
Yeah.
So it's going to be, can I cross out the 2 and the 4?
No, because it's sine of 2x. So we know sine x, where did I write this? We know
1, right?
sine x over x, the limit as x approaches 0 is 1.
Yeah.
I also know the limit as x approaches 0 of sine of 3x over 3x is 1. So literally what's inside the sine x has to be the exact same thing as the bottom. So how can I make the bottom match the top inside? How can I make the bottom be 2x?
Oh, multiply by 1/2.
I could pull out 1/2.
Or pull out. Oh.
Cool. Okay, so wait, if those are being multiplied, this is the property of, let's see, multiplied by a limit. The limit of multiplying by a constant, a function times a constant. So this is literally 1/2 times the limit as x approaches 0 of sine 2x over 2x. So it's just 1/2 times 1.
So 1/2.
Yep.
Oh, so you always multiply it at the end, like.
Well, because this is a constant, so I just pull it out. Because remember, if I'm like, okay, what's the limit as x approaches 0 of 5? Oh, it's 5. Like that'd be a constant function. Whenever you have a constant, it's always just that whatever the number was. Okay. Perfecto. Let's go to Ty. You haven't done one yet. Do you want to try this one?
Sure.
Perfect.
Do it factor the bottom to x minus 1, x plus 1.
Okay, so factor the bottom as x minus 1 and x plus 1.
And then you can cancel out both x minus 1.
So what is happening at x equals 1?
There's a hole.
Exactly. So this is not like you don't have to write this on your test. This is part of the review. But literally when you can cross something out to remove all discontinuity, it's a hole. Wonderful. All right, good job. Keep going, Ty.
And then at this point, you can plug in x equals 1, so it'd be 1 over 2. So you get 1.
Oh, my bad. 1/2. Here we go. Yeah. Perfect. Exactly. Okay. So far, 1 through 4, we've been approaching a single number. Do you guys like not see a pattern with what I'm doing?
No.
I started with you in the middle, and then I was like, well, which way should I go? I was like, let's go. Let's go. Yeah, so I'm going around, and then
Exactly, but you went from shitty to me to mine.
yeah, it's literally a circle. So guess who's next?
Albert. No, I really don't want to.
Spencer's next. Imagine it's a spiral, right? Here's Shani to Noah. All right. And focus. Ready? Here we go. Let's just try. Let's try Spencer, and then Hannah's next, then Abby. So as x approaches infinity, as we approach infinity. So this is.
I was joking. I wasn't laughing.
I know. I see. I was waiting so you could hear me. I care about you as a person. I also care about your grade. Cool. Okay, so limit as x approaches infinity. So as we approach infinity, all the other numbers stop mattering. The only thing that matters is the biggest term, literally the leading term with the highest exponent. So what I'm doing is I want to take the limit as x approaches infinity of 2x squared over 4x cubed, because that's the ones that matter. Have you ever played King of the Hill or Risk or Agario? I don't know. There's 3 different games for you. Lamo, okay. Chabaton. Remember you do rock, paper, scissors, you lose, you gotta follow that person?
Yeah.
So all the little clumps eventually become bigger clumps. Yeah? Okay. Okay, whatever. I'm trying to make it relatable. So as x gets really big, the -5 stops mattering. Because if I put in a number like 1,000 in for x, 1,000 times 1,000 times 1,000, the -5 is very minuscule. The thing that matters, the thing that dominates, is the highest term. That's why we're using the leading term test. That's what we're using when x approaches infinity or negative infinity. We use the leading term test. So here I have x squared over x cubed. Okay, so I know rules of exponents. This will turn into limit as x goes to infinity of 2 over 4x. So we have a bigger power on bottom. So it's approaching 0.
Yeah.
Awesome. Okay, now that I've done one, Spencer, you gonna try this next one?
Sure. 1/3. Wow.
All right, so I look at the leading term, and I say the limit as x goes to negative infinity. Do you have a question? Question? Okay. So just hold in. I know it's really hard. Just wait till after class to talk, okay? All right.
He was explaining the.
So you did have a question.
Yeah, but he already answered it.
Okay. Because the thing is, I'm guessing if someone has a question, you will not be alone. There's probably at least 2 other people who have the same question. I grade all of your guys' stuff. Guaranteed someone else will have your same question. Right? So no one's really making unique mistakes on homework or tests. It's like a group thing. All right, limit as x approaches negative infinity. So Spencer said, let's look at the leading term test. X's cancel out. So this is 2/6, which is also 1/3 because we simplify. Welcome to calculus. Simplify always. 1/3. All right, 1/3.
Thank you.
Hyatt, yes.
If it's x goes to negative infinity or infinity, that doesn't affect.
It does not. No. Because here you would have negative over a negative, the negative cancels out. If you have the same exponent degree. If your degree is bigger on bottom, it will approach 0. Doesn't matter if you're going towards positive infinity or negative. It'll always go, whether it's going towards 0 this way or towards 0 that way. Coming from a positive or negative, it's always going to be approaching 0 at the ends if the x is on bottom, if we have a bigger degree on bottom. And if we have a bigger degree on top, then we actually don't have a limit. It doesn't exist, regardless if it's going to positive infinity or negative infinity. It's a good question, though. Sweet. So this is pretty similar to the test. So, your questions so far? Feeling good?
No.
Not feeling good. Okay. Let's keep going.
No, I'm okay, but no question.
Okay. Is it me? Is it the way I communicate? I went up to this boba place yesterday and it was like 3 minutes till closing, and I was like, "Can I still get boba?" I was like, "Are you guys still selling?" Like, what was the word I said? I was like, "Is it too late for me to get boba?" She's sweeping. No. And I'm like, "Awesome." So like, come in, and the girl's like, "We're closed." Why didn't you answer my question correctly? No, definitely.
Because it's never too late for boba.
No, she definitely knew English. She definitely knew English. This is a little high school girl. All right, so let's go to, let's see, Hannah wrote in. Number 7, use the following graph of f of x equals 1 over x plus 2 for a to c. So what is the limit, Hannah, as x approaches negative 2 from the left side? Negative infinity. All right. How about Abby? What about as I approach negative 2 from the positive side? So from the right side? Exactly. It's going to positive infinity. So as I'm going from the left side, it's going down to negative. As I come from the right side, it's going up to positive. And let's go to tall. What's the actual limit as I approach? As x approaches negative 2 of f of x? Does not exist. Why? Yeah, I'm not approaching the same number. I'm approaching infinities. Well, technically those don't exist. Perfecto. All right, so this is kind of what we practiced yesterday. Find a vertical asymptote, horizontal asymptote, and power function and behavior model for problems 9 and 10. Okay, so let's go through how do you actually do this. Okay, so to find vertical asymptotes, we want to simplify first. Simplify first. Then we want to find horizontal asymptotes. To do that, we compare degrees. And then a power function. So a power function is you divide largest terms from numerator and denominator. So it's more or less what we've been doing already.
So like leading term.
Yeah, literally leading term test, and you divide the x's and simplify it. All right, so those are 3 things we're going to do. Let's go, Gabe.
So you simplify the top, you get x minus 2 times x minus 1. And then x minus 1 can cancel out.
X minus 2 times x minus 1 over x minus 1. You say x minus 1 cancels out. Awesome. So I'm left with x minus 2.
I did the wrong axis.
Whatever. Okay. Okay. So for A, what do you think, Gabe?
There are no horizontal asymptotes.
Yeah, there's none. So for A, there's no vertical asymptote since the denominator canceled. You said no. That's fine. I'm just writing because denominator. Oh my god.
So vertical is the denominator,
Yep.
and horizontal is the numerator? No.
So remember, for horizontal asymptotes, we compare the degrees. So right now, this is the same thing. X minus 2 same thing as x minus 2 over 1.
Yeah.
What's the degree of x on bottom?
0.
0. Degree of x on top? 1. Since the degree on top is higher, there is no horizontal asymptote.
These are the horizontal, no, wait, yeah. The power function and the
The power function is kind of like, would be if I took the limit as x approaches infinity.
yeah.
Yeah, because the power function is describing end behavior. That's what happens when we take the limit as x goes to infinity.
Isn't that what you do also for horizontal?
Yeah, okay, so what if I looked at this? If I do it this way, to find horizontal asymptote, I'm looking at what's bigger, the top or bottom.
They're both just the leading term.
Yeah. Yeah. So you see, oh, I'm left with x over 1. Oh, wait, that's the power function. Y equals x.
What's that? I thought the power function and behavior was as x approaches negative infinity goes to negative
As it goes to positive infinity, negative infinity, yeah. That's why I circled the leading terms.
But what is y equals x?
That's the power function and behavior model.
So instead of saying y equals x again, I can say limit of f of x as x approaches infinity goes to infinity, and limit of f of x is
Well, I'm asking for a power function, not a limit.
what is the power function?
So,
That's the real question.
okay. So power function, so in pre-calculus you learned the power function. So if I have this long polynomial, I can just look at the biggest degree, and it will tell me what the end behavior is like. So if I have something like, I don't know, x to the 14 minus 15 x to the 11 plus 17 thirds x squared minus 5, you know what's happening at the end. Power function. You're looking at the biggest exponent, 14, right? Oh, it's positive. The end behavior, guess what? At the end, it's going to be going to positive negative infinity. So that's the power function. So if I want to write the power function, be y equals x to the 14.
Oh.
But this is only a polynomial. What if I had all of this over, let me move it. What if I had it over, oh, I missed it. I missed part of it. Okay, move it up a little bit. So I don't want to rewrite it. Sometimes I just don't want to do it. Okay, so x to 13. No, I want it to be x to 12. 2x. Cool. Minus 5, x to 6, whatever. So the power function. So really, like, I could describe what's happening at the end. I look at the leading terms. So I have to rewrite it. Divide the largest terms from numerator and denominator. So I have x to the 14 over 2x to the 12. Okay, well, I'm left with x squared over 2. So literally the power function would be y equals 1/2 x squared. That's like what it looks like.
What if there was no x?
No x on what?
On either the top or the bottom?
So let's say, you mean like what our actual problem is right here?
Yeah.
Well, this is, okay. So after I canceled out, so I'm like doing two parts. So over here, there's no x on bottom. Well, technically this is 1, x to 0, because x to 0 is 1. So since I have a bigger exponent on top than bottom, there's no horizontal asymptote. Since I have nothing to cancel out, I'm just left with the x that's on top. So I'm just left with y equals x. Yeah. Let's do another problem to practice. I think I'm on Elliot now.
Yeah.
Yeah. First things. A. We need to simplify first.
So it's y equals 2 over x minus 2 over x plus 2.
Thank you for your enthusiasm. Okay. What about okay, so now I simplified. How do I find vertical asymptotes?
You compare you take those, so it's 2 and negative 2.
Set each factor equal to 0. Set each factor equal to 0.
Sure.
And because our vertical asymptotes occur when I'm dividing by 0. When my number is undefined, when it's undefined, literally I have vertical asymptote. So if I would plug into a negative 2, oh my gosh, it would give me undefined, so that's where I'd have an asymptote. So x is plus or minus 2. Okay. Elliot, what would be my horizontal asymptote?
0.
0. Why?
Because there's no term on top of the bigger ones on bottom.
Exactly. This is literally x is 0 on top. There's no x on top. So bigger on bottom goes to 0. So I gave you a sheet with like asymptote rules and like horizontal vertical asymptotes, and like, I want you to cheat. There you go. Help you out. Lastly, I need the power function. So what I have to do is what, Elliot?
You take the biggest terms
Mhm.
and you divide by, so it's that. It's
Yep.
y over x.
I can't cancel out. So you take you divide the largest terms from numerator and denominator. There's only one term on top, so I have to take the
It doesn't
2.
matter if they have the same
Does it have to have a variable?
power.
The power function doesn't have to have a variable if they cancel out.
Or if there's none.
Or if there's no variable, yeah. I just take the largest term. So if it was 1 on top, then I'd just use 1. Okay, perfect. Find the intervals on which f of x is continuous. I know you're tired, but we got this. Let's just power through. All right, well, it's your first day of school. Maya Schwartz, here we go. Shh. Focus. Shh. 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 Spencer, cut it out. Cut it out. Goodbye. Okay. Thank you. Okay.
I'm not 100% sure, but I'm guessing maybe you said it before.
So we just have to find the domain. Because what does the square root of x plus 6 look like?
You have to flip it.
One more time. What's it look like? Yeah. Yeah, movie theater. Yeah. Okay, wait. So if that's what it looks like, let's think about where it's continuous. It's pretty much always continuous as long as it is defined. So think about it. So literally, what happens to the left of negative 6?
Oh, wait.
It doesn't exist. Doesn't exist. So it's continuous from negative 6 to infinity. And I'm including negative 6. But not infinity.
What the heck?
Because there's no holes, right? So as long as my square root is defined, it'll be continuous. There's no holes here. And the way to find it is when you have a square root, you know x plus 6 has to be greater than or equal to 0. So that means x has to be greater than or equal to negative 6. So it's more or less continuity. Continuity is our domain. Oh my gosh. Wait. One more time. Continuity is our domain. Okay, cool. So as long as our x is defined, like we'll pretty much be our, maybe I'll regret saying that. I'll probably regret it in like a chapter or two, but you know what? Right. For now it's fine because like I want you to see like, oh, literally, as long as x is defined with my square root, it's gonna be continuous.
Are you gonna have like some crazy?
I'm not gonna answer your question if people are stop talking. I'm gonna wait. Okay.
Are you gonna have like where there's like a coefficient from all that stuff like that?
Would that change my domain?
I honestly don't. Maybe that's my question.
Wouldn't change our domain. That would be a good question. Let me see what I did. Yeah.
Wait, why wouldn't it change it?
It changes the y. The number in front is a dilation vertical. It's stretch it vertically, not horizontally.
So what if after the square root is like
Plus 2, like right here.
that would still be y, wouldn't it?
That would still be a shift up of 2.
So it doesn't matter.
No.
Oh, because we're only okay. I'm gonna write a note.
All right. It's not you. I'm not rolling my eyes at you. I did roll my eyes at you.
I wasn't talking to you.
Yeah, well, there's more ways to be distracting than talking. Making like eyelashes of someone and like eyes, whatever. You know, whatever. I'm not gonna like drag out the whip too hard. I'm not gonna drag out the whip too hard. You made your bed. Cool. That's a Nigerian. You made your bed, now lay in it. All right, let's find the intervals which it's continuous. I think we're on Ariel.
Okay, so you have to simplify the bottom, which would be, wait, I need to process this.
That's chill.
Okay, negative, so x minus 2 and x minus 3. And so that would mean you cross out the 2, which means there's a hole at 3. So then, yeah. And then wouldn't there be an asymptote of 2? Is that right?
Yeah.
And there's also an asymptote. So isn't it like it's like 3 parts? Yeah. So wouldn't it be negative infinity to 2?
Yep.
Negative infinity to 2, and then 2 to 3, and then 3 to infinity.
That was beautiful. I didn't have to say anything. That was great.
Tears.
Excellent. So went through, simplified first. So notice we labeled our discontinuities. So f of x is discontinuous wherever our denominators equal 0. Where denominator equals 0. But notice that one of our discontinuities is a whole, the other is a vertical asymptote. It's good to recognize that. Like, you don't have to write it here, but like it shows you. All right, so that would be the no calculator portion. So notice that like most of this stuff you really didn't need a calculator for, because you know how to do square root 25. Cool.
So
All right.
If you look back.
What?
I'm saying it looks really scary once you like look back after you've done it.
That's just my handwriting.
No, it's just like the math. Like
it
it's
is.
like I really just did that.
Heck yeah, you did. Okay. Sure. High five the person next to you. What about her? You left her out. Okay. 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 All right, let's do the next one. Part 2, calculator okay. Write the points of discontinuity and describe each discontinuity as removable, jump, or infinite. So we already, in our previous problem, we kind of did this, but we need to do it now. All right, so notice this is calculator okay. Just to note, at the end of the class, right before you leave, I'm going to put your calculators in press a test. That way, it's the most efficient tomorrow. Guess what? Cool. I'm going to put it in press a test mode. So
are you just gonna put this one?
yeah. What?
Can I leave my calculator charged in here? 'Cause I'm
Sure.
gonna forget to charge it at home.
Yeah.
Honestly,
Yeah, there's plenty of space.
Cool.
Of course, you guys are always welcome to do that, especially because I'm in here all day today. All 5 of my classes are today. And then it's like a Hebrew class, so no one else should be coming in and like taking it. Make sure your name is on it, of course. That way you don't take it.
How long will 10%
I'll write my name on it.
What?
How long will
Charge it. Okay. All right. So I'm trying to make it as efficient as possible. So I'm putting it in press to test mode today. That way, when you walk in tomorrow, you don't have to have a hat. It's already in press to test. Like, we can get going immediately. Coolio. Okay.
So then how do you take it out of it?
So I will take it out probably on Monday when I see you. Because you don't need it over the weekend.
What does it mean?
I have my SAT this weekend though.
Oh, you do?
Yeah.
Okay. So then you can ask during nutrition. You can like go to a math teacher and ask. Honestly, any of the math teachers can take it out. I just know that it's gonna be like people are gonna be finishing at different times. I don't know like reset. My issue so far is I've been resetting people's calculators while they're still taking tests. Okay, she's not even listening.
Sorry.
I've been like resetting people's calculators while they're still taking tests, and that's not fair. So that's why I'm like, okay, let's do it now. Take it all out Monday. If you have an SAT, go to any math teacher, and we'll be fine. Because they can just hook it up and they can just do it in a snap. Okay, part 2, calculator, okay. Write the points discontinuity. Who am I on? Tali, what do you think? Number 12? Exactly. The point of discontinuity is at x equals 0. That's the point of discontinuity. And then B is right, whether it's removable, jump, or infinite. All right, so this, wherever the denominator equals 0, well, let me set the denominator equals 0. Oh, it's literally just x equals 0. Okay. And then what kind of discontinuity is it, Tali? So it doesn't cancel out. If you have your calculator in front of you, you could just, I want you guys to try it out. Put in your calculator, let's see what happens.
Hey, Mr. Calculator.
How do you know?
Because there's no jumping, no removable, right?
Oh my god.
Because you looked at it. You looked at it, right? You looked at it and it's going. Yeah, most times. So it is infinite. All right, let's try the next one. Let's go. There is. So first thing we're gonna do. Question? All right. You have a question? No. Yeah? What's the question?
So it says the
No, I don't.
Absolute value. Absolute value thing is from the 12. Does that affect the equation at all?
It does.
The graph or?
Because if you put in a positive value for x, then you know you're going to have a positive value at the end. If you put a negative value for x, the absolute value on top makes the whole thing positive on top, but it'll be negative on bottom. That's why Okay, next one. So wait, can I simplify the top? Yeah, so x minus 2 over x minus 2. So clearly the x minus 2 cancels out. So I see at x equals 2, I have a removable discontinuity.
Thank you.
All right, use the following piecewise functions. So A, find the limit of f of x as x approaches 3 from the left side. So from the left side, it's coming from the negative, so it means it's less than 3. So I'm going to be using this top one. So I have 3 squared minus 1. So that's 9 minus 1, which is 8. Find the limit. Yes. Find the limit as we approach 3 from the positive side. Okay, so it's from the where we're bigger than 3. So now I'm going to be using this one right here because I'm looking at from where I'm coming from the right side, the more positive side. So I'm coming from where x is greater than 3. Oh, so I'm going to use the side that's x is greater than 3. All right, so hint, A should be in your answer. How nice to say that. 4 times A times 3 is going to be 12A.
Can you do any value?
What?
Can you do any value?
I'm not plugging in any value greater than 3. That's where I'm coming from. It's coming this from the positive side right here. It's saying I'm coming from the right side. Yeah. So that's how I know which one to use, because if I'm coming from the positive side, I'm coming from larger than 3. So that's why I'm using the bottom of my piecewise. Maybe by now you see why piecewise is literally so important to calculus. We use it all the time. All right, cool. Maybe not. Find the value of A, so function is continuous. Wait, for it to be continuous, what does this mean?
It means that it has to equal the same point.
Equal
2 points.
Exactly. So if x squared minus 1 equals, you know what? We already found it. We already found 8 should equal 12A. That's like my y values at my like endpoints. And so for it to be continuous, they have to be the same number. So 8 divided by 12 is 2/3.
2/3.
I don't know. This is on the calculator section, but like, you don't even need a calculator to do it. Whatever. Find the average rate of change over the indicated interval. From 0 to 2 pi. Okay, so average rate of change. Average rate of change. Yes, no.
How do you know when to do the formula where it's like you just plug in, or the formula where you plug in plus 8?
Rate of change is secant. Rate of change, literally, rate of change means slope. So average rate of change, you're using slope equation. So this is when you're going to have f of pi over 2 minus f of 0 all over pi over 2 minus 0, because it's average. If I want an instantaneous, like number 17, where it says find the slope of the tangent. Tangent's at 1 point.
Tangent includes the plus h.
Yeah.
But 20 says find the slope of the curve.
20 says find the slope of a curve at a point, at a single point, is the plus h. At a single point, when you're having a tangent only touching a single point. Maybe I should just do it right now. Okay. What? You can leave it at the very, very back, and I'll try to make sure no one touches it. Yeah.
Should I just leave the hat on it?
I mean, you won't be like logged in anymore, but then I'll tell you which one it is. It's fine. No one else will use. Oh wait, B is today. I forgot Miss Howard's in here. It's fine. Okay, average rate of change. Rate of change is literally your slope. So this is when you have like 2 points. That's when you have a secant. That's when it's not the h, the average. Versus at an instant, at 1 point, your tangent, that's 1 point at an instant. That's when you use the plus h. Okay, cool. So I need to know, what is cosine of pi over 2?
0, 1.
So I have cosine pi over 2 minus cosine of 0 over pi over 2. So this is 0 minus 1 over pi over 2. What? Cosine pi over 2 is 0. Zero's here, pi over 2's here. Remember, cosine's your x, so if I plot the xy coordinate, 1 comma 0,
What the heck?
0 comma 1. So cosine is your x value on your unit circle.
No, yeah. Yeah, that was so weird. That was like so good. Like I saw that, like that was in my head, but like the numbers were right. It was very strange.
Question. Yes.
I thought when it's like -1 over like over a number, you do the
Instead of
bottom
dividing
number
by this.
times the second bottom number. No.
I see what you mean. So what okay, if you have -1, dividing by pi over 2, same thing as -1 times 2 over pi. Dividing by a fraction, same as multiplying by the reciprocal.
Right.
I do see what you mean. So if you have like 2 fractions.
Yeah, I was thinking like 1 divided by 2 divided by 2 plus 1 divided by 4.
Yeah. But here I'm dividing by 1 over 2. I'm not dividing by 2.
Oh, okay.
Yeah. Okay. I don't know if that worked. Okay, let's try the next one. So still average rate of change. So you're taking f of 2 minus f of 0 all over 2 minus 0. So it's going to be 2 cubed minus 0 cubed over 2. So that's 8 over 2, which is 4. Yes?
So should we know the whole unit circle again?
I mean, I assume you know the unit circle.
Like every single one?
At least the quadrantals.
Oh, okay.
Quadrantals, the ones that are literally the
So 1 and 0.
lying on the quadrants. Alright, use the function 2 over x for problem 17 through 19. Find the... Okay. 2 over x for problem 17 through 19. So find the slope of the tangent. So I'm finding tangent at a single point. So let's see the limit as h approaches 0 of f of, well, I'm finding at a single point. So I could just plug that in for my x, because I don't actually have to find the equation. Or we could, doesn't matter, whatever. So you know what, let's just use the point. 4 minus h minus f of 4 all over h. So remember the function is 2 over x, so I'm going to plug it in. So I have the limit as h approaches 0 of 2 over 4 minus h minus 2 over 4 all over h. So this is going to be the same thing as the limit as h approaches 0 of 2 over 4 minus h minus a half over h. All I did was simplify that fraction. So in order to combine my fractions that are on top, I need to have a common denominator. So I'll multiply this side by 2 over 2, and then multiply this fraction by 4 minus h over 4 minus h. So remember, we're taking this negative 1 times 4 is negative 4, negative 1 times negative h is plus h. I distributed the negative as well as write it over one fraction. So I see the 4 minus 4 goes away. So I have h over 8 minus 2h. Instead of dividing by h, I'll multiply by the reciprocal 1 over h. No surprise there, as what happens normally, our h cancels out. Wunderbar. Awesome.
What about the h on the bottom?
So instead of dividing by this h, I multiplied by its reciprocal 1 over h. Cool. Okay, so we are almost there. Did I miss a negative? Oh, this is supposed to be 4 plus h here. Sorry. So h plus, plus, plus. All that does is it changes the, it just changes the plus minus. So that way that's a minus here. Yeah. Sorry. The equation is f of x plus a minus f of x. Yeah. Okay. Alright, so just rewriting, so we all have in one place, negative 1 over 8 minus 2h. And if I plug in 0, I get negative 1 over 8, negative 1/8. That is the slope at x equals 4. Slope of the tangent at x equals 4. Alright, well, I guess we're out of time. But we went over most of it. And then everything that's left is like stuff we covered yesterday and the day before. And review. Alright, have a good rest of your day.